If I'm doing the lowest common multiple, well, multiples are just the number times 1, times 2, times 3, times 4, times 5, times 6, times 7, going on and on forever. We can see that with 6 and 8, if I keep multiplying them, then they both match at 24. They're both going to multiply into 48. If I kept going, they'd both multiply into 72. Those are all common multiples. If I'm looking for the lowest common multiple, I'm looking for what is the first time that the numbers will match up. And in this case, it's at 24. So I could always state and make a list of all the multiples of every number in the set and look for where they match up. If I have 5 and 7, 5 is going to be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, so on. If I'm doing 7, it's going to be 7, 14, 21, 28, 35, 42, and the first time they match is going to be at 35. If I'm going for B, I can list out all the multiples of 10, all the multiples of 15, all the multiples of 20, and I can see the first time that they all match up is at 60. If I'm doing 10, 12, and 14, I could do the same thing. List them all out, and the first time they actually match up is way down the road at 420. Well, for A and B, listing them out works fine, but once you get to, sorry, I should say C, once you get to the last example, it takes a lot. You would have to list out 10 42 times before you finally find one that matches. So there has to be an easier way to do it. Well, the way that we look at this is that we're trying to find all of the different prime factors. So if I look at 10, it's the same as 2 times 5. If I look at 12, it's the same as 2 times 3. And if I look at 14, it's the same as 2 times 7. Well, if I state it like this, ignore this for a second. If I state it like this, where this is just 2 times 5, this is 2 to the power of 2 times 3, and this is 2 times 7. Then all I'm going to do is I'm going to list out all the different prime numbers. I can see that the different prime numbers are 2, 5, 3, and 7. I'm not going to repeat the 2's. I can also take a look at what is the biggest exponent that exists for any of the numbers. In this case, 5, 3, and 7 don't have exponents. They're all to the power of 1. But I do see that right here I have 2 to the power of 2, which means I need to have an exponent of 2 attached to the 2. When I multiply this out, 2 squared times 5 times 3 times 7, it's going to give me that 420 that I'm looking for. So I'm looking for every different prime factor and the most times that that prime factor shows up in any individual number. Let's try that. If I took 15 and 35, then I'm going to say that I have 15, which is the same as 3 times 5, and I'm going to have 35, which is the same as 5 times 7. The lowest common multiple is going to be the combination of all of the different prime numbers. I have a 3, I have a 5, and I have a 7. Those are all the different prime numbers. None of them show up more than once in any individual factorization, so I just need to multiply them together once. 3 times 5 times 7 and get 105. If I do the same thing for 126 and 441, then 126 is equal to 2 times 3 times 3 times 7, or 2 times 3 squared times 7. 441 is equal to 3 times 3 times 7 times 7, or 3 squared and 7 squared. The lowest common multiple is going to be all of the different prime factors. I have 2, 3, and 7 are the different prime factors. I can see that the 2 only has the power of 1, but right here I see that I have a 3 squared, and I have down here a 7 squared. So those both have a biggest exponent of 2. When I multiply that out, 2 times 3 squared times 7 squared, then I get 882. And there's my lowest common multiple. Doing the same thing for C, 22 is the same as 2 to the power of 1 times 11 to the power of 1. 154 is the same as 2 to the power of 1 times 7 to the power of 1 times 11 to the power of 1. And 198 is the same as 2 to the power of 1 times 3 to the power of 2 times 11. So my lowest common multiple is going to be equal to 2, 3, 7, and 11 are all the prime numbers. And I can see that I have a 3 squared. Multiply that back out. And my lowest common multiple in this case is 1,386.